So now I'm going to take a look here. Example 3. Remember, we need to work backwards bed mass. So I'm going to write backwards bed mass up here just as a reminder. So you're looking for addition, subtraction, multiplication, division, then exponents, and then brackets. So that's what we're looking for. So I'm not going to get rid of this 2 first because that's multiplying. This is 2 times. And I'm not going to get rid of this plus 3 because it's technically inside brackets. The only thing I can do is move the thing furthest away from the x, and that's this subtraction. So I'm going to move the subtraction by adding it. 2 square root of x plus 3 is equal to 10. So I've done that. Now I can get rid of any multiplication or division. So I've got a multiplication of 2, so I'll divide by 2. So the square root of x plus 3 is equal to 10 over 2, which is actually 5. So now I'm done those. Now I can get rid of the exponent. This is exponent of a half. That's what square root means. So I'm going to square it. So that will cancel, but I got to square this side as well. So I've got x plus 3 is equal to 10. And now I can get rid of what was inside the brackets by subtracting 3. So it looks to me like I get x equals 7. But I need to, as always, check. So let's put this back into the original equation. So I've got 2 x plus 3, and then subtract 3. Whoops, subtract 3, and that should equal 7. I do not have an x plus 3. I have my 7 plus 3. So hopefully this works here. 7 plus 3. Yeah, that's what I had, right? 7. Yeah, so 7. Oh, you know what? That's actually not correct. You're going to have to completely ignore that. Why did I make a mistake? I don't know why. I got 5 squared here. 5 squared is not 10. So if you were with me this whole time, you're like, Mr. Muller, why on earth? I'm sorry, this is 25. 5 squared is 25. Now, 25 take away 3. Well, that's 22. So that's the answer that I get. So that's what I need to check with. So it's not x plus 3, it's my 22 plus 3. Now 22 plus 3 is 25. Minus 3 equals 7. Square root of 25 is just 5. And now I've got 2 times 5, which is 10. 10 minus 3 equals 7. 10 minus 3 is 7. 7 equals 7. Hey, that's true. So yes, 22 does work. Let's try the next question here. Getting rid of any addition, subtraction? Well, there are none. I mean, there is, but it's inside brackets. So the first thing I can do is get rid of my multiplication or division. So I'll get rid of my multiplication by dividing. So I have the square root of x minus 2 equals negative 15 over 3, which is negative 5. Now I can get rid of my brackets or my exponents by squaring it. Square cancels the square root. So I've got x minus 2 equals negative 5 squared. It's not going to be 10 or negative 10. That's embarrassing. Nope, it's going to be 25. And then I can add 2. Add 2. So x equals 25 plus 2, which is 27. So that's what we have. Let's check, though, before we get ahead of ourselves. Does this work? So I've got 3 square root of x minus 2, in this case it's 27 minus 2, is equal to negative 15. Now the inside is 27 minus 2, that's 25, equals negative 15. The square root of 25 is 5. So 3 times the 5 would be 15. Does 15 equal negative 15? They're close, but way off because one is a positive 15, one's a negative 15. So no, this doesn't work. So with our answer of 27, we thought it would work, but it's actually going to get rejected. And where's the proof? Well, the proof is here. We just checked, and 27 does not get us the answer. So let's take a look here. Ooh, that's awkward. I need to do the next one. Get rid of my multiplication by dividing first. And I get the square root of x plus 2 equals 3 over 2, otherwise known as, I guess, 1.5, but we can do 3 over 2. And now I will get rid of the square root by squaring. I can square both sides. X plus 2. Now this might look intimidating, but really you're just going to square the 3 and you're going to square the 2. Squaring the 3 gets you 9, and squaring the 2 gets you 4. And now I can subtract 2 from both sides. So I have x equals, I don't know where that pen came from. So I have x equals 9 over 4 minus 2. Now 2 is actually over 1, and I need a common denominator, so I'll times this by 4, and I'll times this by 4. So 2 times 4 is going to be 8, and 1 times 4 would be 4. So 9 over 4 minus 8 over 4. So 9 minus 8 is 1, and 4 over 4. So x equals 1 over 4. I don't know if I accidentally hit the ruler button. There we go. So, sorry, over 4. So x equals 1 over 4. Or 0.25, just depending. So that's what our answer is. That's what we think our answer is. But we need to just check. And yes, I do realize this is tedious. And we will learn about domain and range and stuff in grade 12, which will help us do this a little bit faster. But for now, we're just checking. So 2 square root of x plus 2 is equal to 3. That is what I have. But I don't. I actually have 0.25, or I have a quarter. So I've got a quarter plus 2. So I have an answer at 2, the square root. Now a quarter plus 2. Now this 2 is over 1. So we do the exact same thing we did last time. Times it by 4, times it by 4. So we have the square root of 1 quarter plus 8 quarters is equal to 3. And we can add those fractions to get 9 quarters is equal to 3. Now in our unit, we did this, and we are able to split up radicals. So instead of the radical of 9 over 4, we can go the radical square root of 9 all over the square root of 4. And the reason this is helpful is because then we can say, well, the square root of 9 is just 3. Square root of 4 is 2. And then those 2's cancel out, and I get 3 is equal to 3. And that works. So again, just to go over this, we brought the 2 over. Got 3 over 2. We squared it. Now squaring the 3 over 2, like I said, could be intimidating, but it's 3 squared is 9, and 2 squared is 4. We move the 2 over, and so we subtract the 2 over, but we needed to write that as 2 over 1. Now we got a common denominator, which was 8 over 4. 9 minus 8 is 1, 4 over, and then 4 is our common denominator, so we have 1 over 4, or 0.25. And when we checked that, we put 1 over 4 back in. We had to add that to 2. Again, we needed a common denominator, which was 8 over 4. So 1 over 4 plus 8 over 4 got me 9 over 4, which is a weird number, but we can simplify the radical by splitting it up to square root 9 square root 4. The square root of 9 is 3, square root of 4 is 2, and those 2's cancel out to show 3 equals 3. So yes, that is, I agree, this is a lot more complicated and maybe could seem more intimidating with the fraction. But if you take it slowly and if you practice, it might not be as bad as we think.